Okay, I'd like to explain some additional modifications that we made today in our session. And I forgot to record, so we have to go back and look. Now, I have a program called Code Compare. It's a free program you can download. If you look for it on the web, it's called DevArt Code Compare. So if I go here and I do a search for DevArt Code Compare, you'll see DevArt Code Compare. And you can download, you can see that it's free. So I guess it's right here. So that's good. Very nice program. And what it does is it compares new code with old code. Now I made modifications on the code and I want to compare my new code with my old code. So first I'm going to bring up my old code here. On the left, it's going to be on the left. So it's going to be here, I think. Actually, I'll go here and I think it's going to be here. And my old code is here. And my new code, and this is Python code, and then my new code is here. Now what I did was I took the code from the notebook and I merged all the cells and I put them together in a single file so I could compare the two files. All right, so let's see what the changes are. The changes are to enable more manipulation with the different arrays. All right, so if you look here, here's the first change here. When we defined institutions, okay, here we're defining elementary school. So there's a change here in how I define these institutions. Previously, you can see that institution has all of these fields. I want to focus on these here, ID ag, which is the IDs of agents who visit that institution, and PAG, the probability that those agents will visit that field. Now it turns out I want to make those arrays instead of lists, because arrays you can use logical indexing. You can also multiply and do arithmetic operations on arrays. You can't do that on lists. So I want to define these as arrays. More specifically, it's a list of arrays because each individual institution has its own list, has its own list of IDs. But the ID list itself should be a NumPy array. So you can see how I've changed that here. I have 5 different institutions. I have 5 different elementary schools. So I want to define 5 different empty arrays. And that's what I have right here. Hope it's big enough so you can see. It looks like I can actually change the size here by going to Options and then going to Text Editor, Fonts and Colors. I'm going to change this to 12. Try to make it a little bit bigger so you can see, or maybe even 14 should be okay. Let's take a look at that. All right, good. So we can see that a little bit more clearly. You can see on the side here these highlights showing the places where the code is changed. All right. So originally when I defined ID ag and PAG, I created a list of lists, and that's right here. So here I created a list of lists for ID ag and a list of lists for PAG. Now what I'm doing is I'm creating a list of arrays. Now these are empty arrays. The array for the ID has to be an integer array. And the reason is we're going to use that ID as an index. And indexes have to be integers, right? The ID is the ID of the agent, which is going to give us, going to identify entries in different arrays. All right? So here I had a list of lists. Here I had a list of 5 lists. Here I have a list of 5 integer arrays. So it starts here. That's a list of 5 integer arrays. All right? And here's a list of 5 lists. All right? So I did that for elementary school. For high school, you can see the change here. I changed, here I just had an empty list. Here now it's an array of integers. And for probabilities, it's just an array. Here I did it for supermarket. And I also did it for the workplace. All right, so I did all of that to make things more compatible. Now let me jump down to the next place where there's a difference here. All right, now, when I build these structures, the ID ag and the P ag, before I used plus, because plus can add elements to a list. Now I don't have a list anymore. These are not lists anymore, they are now arrays. So I have a different way of doing that. You use the append operation. All right. So append will add this element to the array here. So see here, before I had a plus, and now I have the append operation. And I use that when I create both the ID ag and the P ag arrays. All right. So now I have these as arrays instead of lists. All right, now here's where the difference starts getting a little bit complicated. We have to do the probability of infection when agents visit an institution. All right, this is the simulation loop, and we're infecting agents based on the agents that visit the institution. So some agents that visit the institution will be infectious, some will be susceptible. And those agents have a chance of infecting, those infectious agents have a chance of infecting the susceptible agents. So let's see how that works. I did not work out the probability thoroughly previously. Let's do a simple example to show how that works in more generality. All right. So let's look at an institution and say all these points here are agents that visit that institution. I'll say the two red ones are infected. Now, the two red ones belong to the institution, but they don't necessarily visit each simulation step. So I'm going to say P1 is the probability that agent 1 visits, and the way I have it here, P4 is the probability that agent 3 visits. Not very good notation, but agent 1 and agent 3 are infectious agents, and agent 2 is a susceptible agent. All right. Now, if A1 does visit, then there's a probability P3 that A1 will infect will have infectious contact with A2. But that's only true if A2 visits. Okay. So if both A1 and A2 visit, the probability of infection is going to be P1 because A1 has to visit, P2 because A2 has to visit, and P3 because there has to be infectious contact. All right? So the probability that A1 infects A2 at each simulation step will be P1, P2, P3. Similarly, the probability that A3 infects A2 is going to be P4, P2, P3, because P4 is the probability that A3 visits. Probably A1, A2 visits is still P2. Probably infectious contact is P3. All right? So you might think, well, to get the probability that A2 is infected, you just add these two probabilities. But unfortunately, you can't, because there's also a possibility that both have infectious contact, and then you'd have to subtract off this result. Now here it's just the product of the two individual probabilities because we're assuming these events are independent. So if I was going to do this directly like this, I'd have to take this probability plus this probability minus this product. The problem comes in when you have 3 or more agents who are infectious. Well, how are you going to do this? It gets very complicated. We have to do this a different way. All right? So what we're going to do is use complementary probabilities. Okay? Let's compute the probability that neither A1 nor A3 has infectious contact with agents, with susceptible agents that are present. Okay? So if we take that's the complementary probability. Instead of computing the probability that these agents infect somebody, I'm going to find the probability that these agents don't infect somebody. And the reason why I do that is that if someone's not infected, that means they have to be not infected by all infectious agents. And that's the intersection of the individual non-infected probabilities. So I just take the product. Okay. If I know the probability that agent is not infected, to get the probability that agent is infected, I take 1 minus that. So that's the strategy. Okay. I had a similar strategy before in the original code, but now this is more sophisticated because I'm taking into account the fact that these two agents visit with different probabilities. All right, so let's go ahead and see how that works. The probability that neither A1 nor A3 has infectious contact with the agent that's present. Okay, the probability that the agent has no infectious contact with A1 is 1 minus P1, P3. Now I'm assuming that agent A2 is attending the institution. Okay, so P1, P3 is the probability that agent 1 infects a susceptible agent. 1 minus is the probability that is not infecting. Similarly, the probability that A3 does not infectiously contact A2 is 1 minus P4, P3. Okay. The probability that A has no contact with either is the product of these two, because the different contacts occur independently. Right? So this is the probability there's no infectious contact with either. So the probability that A2 has infection contact with at least one is 1 minus this, the complementary probability. Right? But this is only true if A2 visits. So I need to multiply this by P2. Okay? So the total probability that A2 gets infected at each simulation step is P2 times this factor here. Okay? Now this is for two agents, but I hope you can see how this would work for more than two infectious agents. I just need to multiply all these factors for all the infectious agents, take 1 minus that, and multiply by P2. All right? So that's how it works. So what I take is the probability that an agent visits, which is this, inst Pag, times 1 minus, and then I have to take the product over all infectious agents of 1 minus the visit probability times the infectious probability. Okay. Now, how am I going to select the infectious agents? Well, that's where I want to use logical indexing. And that's why I changed this from a list to an array, because I want to select only the infectious agents from this list. This list is a list of all of the agents that visit the institution. I want to select only the agents that are infectious. Okay. So I'll keep this in mind. We'll be flipping back here to explain the equation. But let's go back and look at how the new equation is. All right. Now it turns out I've changed this for loop here because I need both the index of the particular institution and the institution type. Remember this inst.id. This inst.idag has a array of visiting agents for each institution of each type. There are 5 elementary schools, so there are 5 lists. Okay, so this is the actual list for each elementary school, and this is the index, 0, 1, 2, 3, 4. So this tells me which list I'm looking at. All right, that's something I added because I'm doing this more completely. I didn't actually use that here, but I have to use that here. All right. All right, so what do I do with what do I do in the next line? Notice this here. Here we have agents.status of this list greater than 0. These are infectious agents. Okay? These are the infectious agents in the current list of agents who visit the institution who are infectious. Okay? So for instance, if in this case here, if this was agent, 007, all right, so whatever. So perhaps this one is agent 7. Let's just do this. This was agents 7, 4, 9, 6, 12, 15, and 24. If I selected the agents that are infectious, it would select 9 and 15. All right. So I would have a list, actually an array, of the 2 infectious agents, which would be 9 and 15. All right. And what I'm going to do is I'm going to take the visit probabilities of those 2 agents. That's exactly what I need in this formula down here. The visit probabilities of the 2 infectious agents. All right, so I'm doing the logical indexing that I'm referring to down here. I'm doing this logical indexing. All right, so these are the probabilities of the infectious agents that visit. All right. Now what do I have to do? I have to take the product of these results. I have to take 1 minus this and take the product. Okay, and that's what I'm doing here. I have NP dot prod, which is the product. I have the 1 minus, which is there. And I take these probabilities and I times this inst PF. This is the infectious probability of any visit. This is a number which only depends on the institution. All right. So that's the factor right here. So I've completed this factor here. All right. Now finally, I need to multiply that by the probability for each individual susceptible agent. All right, so that gives me here. So these lines here implement this formula here. All right, a little bit complicated. Takes a little time to understand. Takes some time to understand how that works. All right. Now I also added this line here because I want to, later on, I want to only count the infectious who are, the possibility of infection for those who are susceptible. Okay. So these are giving probabilities of infection, but someone can't be infected if they're not susceptible. So here I'm setting equal to 0, the infectious probability, if the agents who visit are not susceptible. All right. So for example, in this list here, suppose these here are, whoops, not sure why it's doing that. Let's go back here and do this again. Okay. In this list here, for instance, only 7, 4, 6, 12, and 24, those would only have non-zero probability of being infected. If this one turned out to be recovered, then that also would be left out because its status is not 0. All right. So here I'm just going to be counting the infections that actually take the infectious contacts with susceptibles. Okay. All right. And I did the same thing for homes as well. I'm going to count only the infectious contacts that are with susceptibles. All right. And I'm going to use that later. All right. Now, besides that, I think that's pretty much all the important changes. I will update the Excel also to reflect these changes. But the difference is, to summarize, that the lists for agent IDs and agent probability of infections were updated to arrays so that we could do logical indexing. And also I corrected this infectious probability of those who visit the institution because what we had before was not accurate. All right, so that's pretty much what we did. All right.